Welcome to wasmCloud Wednesday for Wednesday, January the 12th, 2022. We've got a big meeting today, but we've got a couple new folks. We'll let introduce themselves. Nikki, do you want to say hello?
Hi, my name is Nikki Sonkar. I'm a principal security architect at T. Rowe Price. I'm just very interested to learn about this technology. I think it's pretty fascinating, the small footprint. So I've just started with the demo, so I'm really just very much in the ramp up mode right now.
Thank you for coming, Nikki, and it's good to see you here. Ross, how are you, buddy?
Hey, I'm great. So everybody, I'm Ross Thanopoulos. I'm a software engineer turned security engineer. I'm now one of the early security hires at Weights and Biases, which is an MLOps platform. And I'm very interested in the machine learning capabilities of wasmCloud and looking into how to potentially leverage both.
And then Dan.
Hey everyone, I'm Dan Norris. I recently just started as infrastructure lead over at Cosmonic. So I'm pretty excited to dive into wasmCloud and sort of all the potential that this technology has. I've done a little bit of work with like what used to be wascc, kind of similar boat to I think a lot of people here. Was like just working on stuff full time. So
You cut out just a hair on us, Dan, there, but I think we got the gist. And as usual, we like to start our meetings with a demo. And Jordan, I think you've got a demo for us this week.
Hopefully, if it all works, let's try it out. All right, let's see if I can share the right screen. Share. Cool. Does everyone see two windows here?
Yep.
Cool. So what I did, I had a little free time on my hands this week, so I went into looking around how I could do a little wrapper shim, I don't know what you call it, more or less doing a Go port of the control interface client that we already have over here on the right. So what I did was I went through, pretty much followed this structure and code naming convention almost as closely as possible, and I came up with a functioning Go library that implements pretty much all these calls to the underlying nats that in the same manner that, as Brooks told me, Wash and the washboard do with Rust and Elixir. This is more or less the Go implementation of that. So yeah, we can walk through the code here in a minute if we want, but you're not going to see anything that too special. All you're going to really see is the topics that are very well documented on wasmcloud.dev. And pretty much I followed the exact logic that that you can find in the Rust code here. So more or less, now if we were to look at this main.go, I've just written this poor man's CLI that just reads kind of like the R as we go in, and we just start throwing the start actor, the stop actor, the FA actor, and I just wrapped all of them very lightly, and then more or less we get a functioning like Go wrapper that can call the host, get information about it, and I have hard coded all of the values in the main.go here. So when I do actor start, what it's doing is it's taking the ecto actor, it's starting the ecto actor. When I do the provider start, it is taking the HTTP server provider and starting it. And then if I do link start, and link start is not really an accurate term for what it's doing, but for the sake of this demo, me remembering what the commands are, I named it start. Then it goes through and it'll actually link them together. And if we look here in a second, I'm looking at the washboard over on my other screen. So as soon as it goes healthy, we will be able to see that. Come on. Oh, I didn't expose the port. Well, if we were to go into the Docker network and run that, the Echo actually does work. I rebooted it right before this to get a clean environment. So yeah, I mean, that's really where I'm at. The code's all sitting here. And I would love any feedback from any Go folks out there, because I'm not the best software developer in the world. So there's no real error handling. There's no real anything right now. It does a lot of assumptions. It grabs the first host, but yeah, hopefully I can just start a little bit of a Go effort and see what we can do with it. And that's all.
Jordan, thank you so much. You bring so much to the table. For those of you that are new, Jordan also runs a lot of our community stuff. He, makes sure that our meeting recordings get pulled together and posted on all the places, on Reddit and YouTube, as well as he did, a bunch of the training stuff that's out there. He's designed cheat sheets, all kinds of stuff. So Jordan, I thank you so much for being such a wonderful community member and continuing to just figure out ways that you can jump in and help. Brooks, you wanted to jump in maybe?
Yeah, I had a question and then maybe some comments. So I'm not the goofiest gopher or whatever the Go people call it. But what, Jordan, with the structure of this wasmCloud Go repo, I know that you're running the examples like a command line interface.
Yeah.
Could you, is this kind of structured like a library? Like, could you put this out on package.go.dev and have people, be able to call it?
Yeah, so I actually wrote a second one here. It's also in the examples folder where it is doing just that. And I shared a Git pod in Slack somewhere that that imported the library as you normally would. But yeah, you don't have to. It's written in the form of a library using Go modules, so you can just pull it in with that right there. And this right here, if we were to just dot go run this, it would essentially stand up the Echo actor with the server and link them together.
Okay, awesome. Because I was wondering, because with the way that you're interacting with it on the command line, it's very Wash-esque, which is cool. And then, something that we could definitely leverage with all the Go code out there is if you can use this as a library, which you are doing, that would be awesome to be able to, from a Go application, administer somewhat a wasmCloud cluster.
Yeah, for the sake of transparency, the only reason that little wash-like thing exists is because I was nervous that I would mess up the demo. So I put that together in 20 minutes so that I could just remember 4 commands.
No, it could be, it's nice and useful. So I did want to say, Jordan, thank you for starting on this. I know that we kind of talked about it. I think it was yesterday. I think you whipped this up really fast. But this is something that kind of lends itself, with the community, to adding support for different languages, and not necessarily for actors or capability providers, but getting some of the tooling a little more formalized, especially with Go. Because for things like the control interface, we've technically had support for any language on the control interface that has a NATS library. If you hook into the right topics, then you can issue control interface commands. But having these kinds of libraries really help the barrier to entry, and not making you have to learn about a NATS library, not making you learn about, maybe proprietary is the wrong word, but the exact structure of you need to do a request multi on this topic, a request on this topic, a publish on this topic. So, reducing the barrier to entry by being able to bring in more people is definitely nice. And I think that kind of a next step for an effort on the Go side is to start looking at the the effort of adding code gen for our structures, because things like the start actor command, Jordan, I'm sure you probably had to hard code that or set that up in the library. But if we can generate it from our Smithy structures, then that again reduces the barrier to entry. It's something that we of course have to prioritize as far as when we're getting to the point where we can create a Go code gen, but that would definitely be a good next step here.
Yeah, definitely. I had the Smithy files up on the screen. I was more or less just going down and creating Go structs manually as I went. So yeah, exactly.
For the folks that are new, the sort of nuance here is that, Golang does not have incredible support for WebAssembly at the moment, and it's not supported right now as a sort of first class language in the ecosystem. So we do have people that come and ask for that support. Just recently, we had Yedu come by on Slack and spend a little time talking about it in some of the channels. And we're still trying to prioritize and figure out what the roadmap is for adding languages. Jordan, one ask that came up is I had a sidebar with Steve based on the Slack conversation that we had about seeing if you and Steve could maybe shepherd some of this forward a little bit. If that might be something a direction you were considering going, is adding support for auto code generation and things like that. And we thought, honestly, the most important thing to capture in that would be the process of how do you add a language to wasmCloud. And I thought that would be something you've done. You've done so much wonderful work around, lowering the barrier to entry for wasmCloud, that might be something that you and Steve could do a sidebar on as a project. And I don't need an answer now. I'm not trying to put you on the spot on that. So maybe you guys can follow up on Slack on that particular topic and go from there.
The answer is always yes, Liam.
Oh, you're so awesome, Jordan. So Steve, maybe you can grab some time with Jordan, and you guys could sketch out what the steps might be in that work stream. And I think this would probably be a new section over at wasmcloud.dev on how would, if somebody wanted to add assembly script, what would be what would be all the key steps that they would need to follow, for example. Kevin, did I capture that correctly on the discussion we had the other day?
Yeah, I think so.
Okay, super. Great. Now let's turn over to, we have a new sort of sub-effort of folks that have come to the community that are working on the machine learning stuff. And Ross, I know that was one of the things you were interested in talking about. We're still in the design scoping phase of this. But Steve, you were at a meeting that we had yesterday afternoon that I think was incredible. The meeting was recorded, and we will have that up on our YouTube channel shortly if people want to get caught up on it. But Steve, I think you have a sort of summary that you can sort of walk people through. I probably need to give you the ability to share your screen, don't I? Yeah, that's why you're not sharing your screen. It's like every darn meeting. All right, Steve, go right ahead.
So yes, there's some exciting. That's weird. I'm gonna take a guess. Oh,
share the meeting agenda, Steve?
Yeah. So I can't share it without restarting Zoom. I'll talk through it. So it's there's a machine learning repo inside the wasmCloud org on GitHub. And so there's a new subgroup that has just formed that's really interested in moving forward with getting machine learning support in wasmCloud. And Christoph took the initiative to create this document here and describe some models for how we might support it. And Liam, could you scroll to the first diagram that has the inference engine and the model? That's that one, right? Or the next one that has arrows. So what the idea is to have a, we want to support multiple models at runtime. And part of that is so that an actor can make a decision to switch between models, for example, so you could do A/B testing. And we want the inference engine to be able to work with different libraries like Tract and TensorFlow that can take advantage of native CPU instructions and GPUs that can really speed up machine learning models. So the inference engine would be implemented as a capability provider, and that'll let it have access to those native CPU capabilities. In addition, we talked about using a Bindle server. Bindle was an effort created by the Deus Labs that stores an archive of files in a server. It has some similarity to an OCI registry. And models could be loaded into the Bindle server. The inference engine could pull them down and run them. And so another source of inspiration is the wasmN interface that was created by Andrew and team at Intel. One of the things that interface does is it abstracts the backend engine that you're using, like whether it's Tract or TensorFlow. What we want to do is take that interface, turn it into a Smithy interface, and make that a capability contract for this inference engine capability provider. And that will allow actors to be able to invoke machine learning models in wasmCloud. So I definitely want to mention the contributions done by Christoph and Bailey Hayes and Andrew, who I'm not sure on this call, but there's a lot of excitement in this space, and we welcome all participants. And you can read, we'll keep updating this repository with progress. Are there, did I miss anything in that overview, or are there any questions?
I've got a couple questions, Steve. When we think about, the first engine to be supported, we've got a number of options from OpenVINO, which is out of Intel, TensorFlow, which is obviously originally out of Google, or the Onyx folks. Was there sort of a discussion around what folks were looking at supporting first with wasmN, or through the wasmN sort of interface?
Yes, there was definitely a lot of discussion about that. And the document that Christoph wrote here mentions Tract. In the community, in the AI community, TensorFlow really has a lot of momentum, and there are so many people working on that we have confidence that it's going to be around for a while. So we think that would be a good place to invest efforts. But like a lot of things in wasmCloud, we'd like ultimately for people to be able to make choices and try out different implementations. Some people like PyTorch, some people like TensorFlow. So ultimately, there will be several. I think it's like almost certainly the first implementation will be either Tract or TensorFlow, and between those, it'll probably be TensorFlow.
Got it. Okay, that's that's wonderful, Steve. Thank you so much for giving everybody the summary. And again, the meeting actually went on for I think over an hour. We'll get that up on YouTube. It looked really interesting. I had to jump off a little early. Brooks, thank you for staying on and recording that yesterday. I'm super excited about this. We're absolutely going to try to get this ready for KubeCon Wasm Day, which is a good segue to our sort of community updates. Just FYI, the submissions for Wasm Day, Cloud Native Wasm Day EU for KubeCon are now open and will be open through February the 28th. So I'll get that out on Twitter a little bit later. We're still going to make some minor updates on what we're looking for, but it's very similar to what we've been looking at before, which is any user-focused or community-focused use cases that broadly fall under the big umbrella of Cloud Native Wasm. Now, I've got some even better news in that Cloud Native Wasm Day for anybody that is buying a full or a KubeCon admission anyway will be free for online attendance. There will still be a charge if you plan to attend in person in Valencia, Spain in May. I plan to be there and go from there. We've sent out invites to a program committee, which is we're trying to do a more European-focused program committee to bring folks along. We're working now on agenda. New to the program this year will be some training that we're going to try to facilitate. I'd like to get it facilitated in a way that is very inclusive and allows people to participate, whether they're on present or remote, and that so not only online but also free as well. So we're still working through a few options there, but expect additional updates there. So I really encourage everybody in the community that's working on interesting things to tell your story, share what you're working on, and I know we're looking forward to continuing to make this event bigger and better with each passing month. Any questions about Community Day? I also know that there is a WebAssembly event that is being planned for the EU in London in the next few months, but I think it'll be next week or so before we're ready for any details that we can share. We can pass on about that for anything that's happening there. Just open floor. Are there any other WebAssembly events that people would want to mention or sort of put out on the community call? Okay, super. Let's go ahead and just open up the floor. I think we've got a few different development efforts that are underway under the open source umbrella. wadm really comes to mind. Jonathan, Kevin, I know I've seen commits going by there. Is there any sort of questions or work that we'd want to maybe socialize or bring in for discussion on the call at this point?
I can show what I did for Amnesiac. It was, I guess, a call out for help that Kevin actually had when he did his commit. That is mostly implemented, but it needs to be dog-footed and see where it goes from there. So if I can present, that would be great. I'll share my screen.
You got it. You should have permissions.
So this is the change that actually went in, and I'll call out a couple of things here, and then I'll actually go through a test that shows.
Can you zoom in?
Yes.
Is this like a 54-inch Samsung television that you're on?
It's 30-something inch, but yes.
Are those binoculars, not glasses? A little closer there.
Great comment. So Amnesiac or Amnesia is a database, I suppose, that's built into Erlang, part of OTP. When I show some of the information, I'll actually show that it goes to a file system. What's really cool, at least as far as I understand, is that when you configure it as Amnesiac, you can actually have replication go through from one VM to another. It is surprisingly fast. I don't know why it's so fast, but it's fast on running unit tests, which I was really surprised by. So like the first file we're looking at here is a store, and the call out here is that I'm actually making disk copies as opposed to making RAM copies. So that actually gives the persistence as opposed to disappearing completely. And then the second one is that I ended up creating, well, I did create an interface with a callback. So it's modifiable, I suppose, and we can introduce other backends in the future if that's really what we want to do. But since this is just a test, I had it in such a way that right now it's just going to Redis cache, and then we can add something for Amnesia cache, which is a function that, well, which is a module that we can call out. And then the rest of it is code. So if I jump into my repository here, some of the things you see on the side here is me creating the database. So this is what actually gets created. They're not readable, and I haven't actually looked at interrogating them using any of the Amnesia commands yet. And then here I have basically a configuration that shows the whole thing being instantiated. So this is the lattice store. If I go to definition, which doesn't work, it's under here. So this is what the store looks like. I have a just DSL at the end of the day. This actually creates all the attributes, and I'm indexing on a prefix as opposed to an ID. I did notice that this was mandatory, even though it actually formatted up here. ID is mandatory. If it isn't there, the tests actually don't create the database. It does die silently. I haven't looked into exactly why that is the case, but it is required, even though in the code, we actually use prefix as our index, which is what I've done here, or well, in the implementation as the code. Then if I look at the test, which is here, jumping back in here. So this is using cluster, an extension for a mix, which actually lets you go from cluster to cluster, which is this guy here. And that lets you test across clusters and also see what happens between the two, which is how I actually checked or found out that the replication is really good. So in this case, I'm doing a quick dirty write here as opposed to a transaction, and then a dirty read as opposed to a transaction as well. And in the second case, I am doing a distributed system. So I have two nodes running, and then I do all of this stuff, which is a bunch of asserts, but I'm writing to one node and I'm reading from another node. And that is surprisingly fast. So that was the callout that Kevin actually had. So if I run the test here, which is just running the entire one, well, which is what you just saw before, but it'll run and pass the whole thing. So that gets called out when we want to write a lattice out in, I guess, so this is the cache, which is an interface. Then we have the Redis cache, which actually now implements that interface. And then the amnesiac cache, which is doing the same thing, but through a transaction here. And then the code that actually uses it is what I showed before, because I don't remember where it is. Well, it's actually up here where we call it in this file, so on the deployment monitor. And yeah, so that's kind of the gist of everything that is there. And then it comes down to actually hooking it up and actually testing it out and seeing whether there are changes that we need to make in terms of like, is the ID actually going to conflict or not? As an example, even though that's actually not set as a primary key in this case.
Hey, Janice, would you do me a favor? When we play this back on YouTube, it's going to be a little hard to see this. Could you maybe drop out just a couple links into chat that we can capture, or maybe either DM them to me and Jordan on Slack? And what we'll do is we'll actually maybe drop in little like subtitles to point people at least at where this is in case anybody's following along and wants to jump in on the wadm stuff. I know that you and Kevin have been making great progress on this together. But I think I think this is possibly interesting to multiple people, and it just may help to make sure that we bring folks along with us.
Yeah, make sure I use the other screen the next time. Sorry.
Yeah, this is amazing stuff. When I originally put in that commit, like, you know, it'd be nice if I could get Amnesia to work. I didn't actually expect anybody to come in with a PR to make it work. So that's awesome. The thing that I couldn't get working in my local branches with Amnesiac or with Amnesia in general is that when you look at the Amnesiac interface where you configure it, the list of nodes that it uses for replication is fixed. So, you know, if I start up my cluster with a known fixed set of nodes, then Amnesiac works wonderfully. What I couldn't get working is when I use both cluster and horde in auto member mode, where cluster is using dynamic discovery of nodes. What happens there is Amnesiac, at least when I tried it, it didn't update its own list of connected nodes. Like, so it's essentially unaware of cluster's dynamic discovery. And so once it started up with a fixed node list, it would never append to its list of nodes. And so I see, like, you've got the amnesiac supervisor there. You see how it's called, it calls node.list. So if I start up a node using discovery as the first node in my cluster, that node will never become aware of newly discovered nodes, because the amnesiac supervisor is unaware of updates to the cluster membership that cluster.supervisor does. So that was like the key thing that I could never figure out how to get working locally. So like, if
I know that was something that was raised with Horde, and why people have actually gone to Horde as opposed to using global. But I haven't actually played a lot with Horde yet. And how are you using it?
Yeah, so I figured out, so what's not included in here is, like, where you look at where we've got horde.registry there, there's another flag you can pass to it called, where you can say members and then send it the atom auto. Cluster also has the same option where you can set members to auto. And then you can supply like a gossip protocol for how the cluster thing discovers other members. And so what I was using was cluster in gossip mode and horde in auto member mode, and those two work together perfectly fine. So like the horde registry discovered all the other nodes, but what happened was amnesiac wouldn't update when new nodes joined, and so I couldn't figure out how to get over that problem. So that's kind of why that's where I was stuck when I added that comment to my commit there.
Okay, I didn't actually know that, but I mean, when I looked at the amnesia code in GenServer, it seemed to actually have the detection in there. But to your point, I was doing it through a test as opposed to doing it manually. I can try that.
Yeah, what I'd like to be able to do, and I just haven't had time yet since you submitted the PR, is to take that PR, put everything in gossip mode with auto members, and then see if amnesiac actually replicates. That would be, if it does, that would be mind-blowing, because like you said, amnesiac's replication speed is almost illegally fast. I don't know what sort of black magic they're using, but
I was really surprised. I wasn't expecting my test to pass, and I was like, whoa, okay. Yeah, it's impressive for sure. But yeah, I will look into this stuff.
Yeah, if you figured that one out,
You know what,
that'd be awesome.
I made a big mistake when I kind of handed the mic over to you, Jonathan, Kevin. Not that I handed the mic to you, but that I didn't really give an intro around, like a reminder around what wadm is. Jonathan, would you maybe give us a 2-sentence in your words, like just the elevator pitch for what does this enable in the big picture for the ecosystem? And then maybe Kevin, would you also throw in 2 sentences, because I'd love to hear like just a summary of what we're really doing here, because I know we just like dove to down into the code here without sort of saying like, hey, this work stream is really about.
So the genesis of this was to facilitate, I guess, the user to migrate, or at least use in parallel Kubernetes as well as wadm, and provide an easy migration path. So the part here was to take an OAM spec, an open application model spec, use that to instantiate or initialize actors and providers in OTP. The washboard, which Jordan, I guess, kind of was going to show, is one way that you can do it, and this is a programmatic way of actually doing it through a specification.
What are the couple of big standards that you guys are aligning to, as far as like at the 50,000 foot level that people would have heard of before, that are perhaps part of the CNCF or something along those lines?
I mean, so there's not really anything specific here that's a big giant industry standard or something like CNCF. So, I mean, basically what wadm is an implementation of an autonomous controller pattern. And what we're doing is wadm will observe a lattice, and then it takes your desired state, which comes in the form of a big slab of YAML or JSON. And then, you know, it uses a control loop to ensure that, you know, whatever it is that you wanted to be deployed is deployed. So, you know, Jonathan mentioned that, you know, you can use the wasmCloud washboard to manually deploy an actor, but what you can do, or what you'll be able to do with wadm eventually, is be able to say things like, I want a total of 20 actors, and I want those spread across n number of hosts that all have the label, this set of label constraints, and you know, things like that. And then wadm will auto maintain that application for you. So if something goes down, it'll bring it back up. If something scales too much, it'll scale it back down, and that sort of thing. It's like a babysitter for your wasmCloud applications, and it adds the logical definition of an actual application. So you give wadm a spec for an application, and it deploys the thing for you.
The softball I was trying to lob over Kevin with the alignment was to set you guys up to talk about Open Application Model, OAM, with CNCF stuff.
So I mean, OAM is just like a tiny little piece. It's a way that we're standardizing on representing an application model, and that's really the only involvement there.
It was clearly a bad pitch, you know.
Kevin, if I may hijack this a little bit, this is one of the things that I probably haven't wrapped my head around, and I think you have it in your head, but I don't quite understand all the way yet. So some of the stuff that we discussed just now was basically something like this, right? So you have an OAM spec that comes essentially through host core, which is the OTP part that we're talking about, and then it gets provisioned, and then you have a diff, and then you have a control loop that actually goes through a apply back off, and then eventually gets consistent. Something that I haven't quite understood yet is how the state, which I'm calling here as a state, and I guess we're interleaving lattice and state together. So wasmCloud host, which is the part that we're calling washboard, has a state that it uses to update the user interface, so to speak. That has an actor, a provider, and a link. And then we have wadm, which also has a state, which goes to the lattice observer. So this is the part that I don't quite understand how this link actually works. And whether we're actually segmenting those, which I think is the way that we're going. And if that's the case, then how the washboard would actually know everything that happens in the OTP or the lattice, or the terminology that we're using there.
Yeah, so I think if we go to the spot in the diagram where you mentioned host core, I think that's probably where the pattern diverges. So host core is not responsible for anything in the OAM spec. Host core doesn't know what wadm is. It doesn't know what a wadm application model is. It should remain blissfully ignorant, along with washboard. So the way that this is planned to work is that when you bring up an instance of wadm, you will then deploy an application spec to it, and then it will issue lattice control commands to the lattice in order to bring about the state that you desire in the application spec. So for example, if you say, if your app spec requires 3 different actors, 10 link defs, and 5 capability providers, then what wadm will do is compare what it observes from the current lattice with what you desire, and it converts that into a list of actions, which it then sends over the wasmCloud control interface in order to make real. So in short, Host core is not involved in the concept of an application. It remains just a quote unquote dumb scheduler for wasmCloud entities. And eventually what will happen is that the observed lattice code inside washboard will actually just be migrated to use a lattice observer. And the stuff that washboard observes should be considered like for convenience only. It's just sort of as a nice to have in order to give the washboard UI something to show you. But the lattice observation that wadm does is actionable based on multiple deployed application specs. So maybe implicit in this work is also the notion that wadm will manage multiple application specs at the same time across the same lattice.
So is the state being segmented or not? That's something that I haven't actually understood.
The state is not segmented. It's just that both wadm and the washboard are accumulating state using the same set of rule applications, but they're accumulating state for entirely different purposes. The stuff that washboard uses is disposable and for convenience only in order to make the UI have a little bit more information. And wadm state is used to trigger control interface commands.
When you say accumulating state, I mean, this is, I guess, one of the PRs that I kind of questioned before, whether there is the need to do an integrity scan where one thing knows, well, one thing is actually the record, I suppose. And I just don't know whether there is going to be a divergence case or not. That's kind of where.
So if there is a divergence, it doesn't matter because the record of truth, the thing that matters is what wadm maintains in its supervisor hierarchy as the view of the lattice. Anything that's in a wasmCloud cache is disposable and not the system of record.
Mm-hmm.
So I guess to your other question is no, we don't need to do an integrity scan where wadm and washboard compare notes and see which one has the most accurate representation. Whatever wadm sees, that is the authority of record.
And so the lattice observer actually observes the entire lattice. Or I think right now we're also saying that we can have multiple hosts in terms of there is an option to do prefixes.
So yeah, wadm is designed to support multiple deployments, and by deployment, that's an instance of an application spec model, as well as multiple lattices. So you can have wadm observing multiple lattices and then maintaining multiple application specs per lattice. So you could have, as long as the NATS credentials point to the same shared topic space, you can have wadm maintain applications in like a test lattice and then some other lattice, and as long as they have different lattice IDs, then wadm will observe both. So the logic that you saw in there the last time I put a commit in was when you start a deployment manager, which is responsible for the control loop, it will also check to see if there is a running lattice observer. And if there isn't, it will start one. And then there's some more code that needs to go in there that has yet to be put in a PR that will have the lattice observer do, or not have the lattice observer, but it'll have the wadm kick off a couple of things across the lattice so they can query the lattice state from, so if it's the first time this thing is ever run, it needs to do a probe so that it can figure out the lattice contents.
thank you for that. Clearing out a bunch of stuff for me
That's
in my
awesome,
head.
Jonathan. So Jonathan, do you feel like your questions are answered as far as like the few things that you were, that you're, so you can keep moving forward on this, or?
Yeah, I mean, as I play more, I actually understand more, but it was just things that I needed to understand better, or at least understand what the vision is, because not all the code is written yet. And then go from there.
Yeah, and Nikki, to your questions, where my understanding is that this takes care of the reconciliation between desired state and current state, and then you could use something like a horizontal autoscaler on Kubernetes to drive that eventually. Kevin, did I communicate that correctly?
So this is designed to operate with or without Kubernetes. So when you give it an application spec, you tell it how you want your actors spread over the list of available hosts. And if you're running in Kubernetes, then you can use the higher level scheduler to start new wasmCloud hosts, which would then, so because it's running in a control loop, like what you could see happen is once you have a spread defined in your application model, and Kubernetes then spins up 5 more wasmCloud hosts, that could affect what wadm wants to do with where it schedules your actors. So it could then reshuffle in response to those hosts starting.
Got it. Yeah, and I definitely understand that this could be driven with or without Kubernetes. I was only just using that as an example. Nikki, did that answer your question, or did you have any other discussion you wanted to ask about this at high level or any level really?
No, I mean, I just, again, I'm just trying to piece things together, but I mean, it just seemed to me that was, you're adapting your actors based on a spec, and it seemed that spec was kind of rigid. So I was just wondering, was the future intention, again, I'm thinking in terms of some of the analog would be something like an auto scaling group, right?
Yeah.
Based on certain triggers of load, go up or go down, right? But that doesn't seem to be what this is in and of itself. So it seems to me like that layer could be added when and if it was needed.
Yes, and wasmCloud does have some metrics that you can source out, for current status. But I think we'd probably want to have a broader discussion around, what some of those generic pieces might look like if we wanted just to function independent on wasmCloud. But we felt this was a clear scoped set of component that needed to exist to enable the downstream work. And of course, what we're really driving at is that one of the amazing properties of wasmCloud and WebAssembly is that these actors are incredibly tiny and they have a really small memory footprint. From a size perspective, they're looking at 20 kilobytes to 2 meg depending on language. So you can do a scale event very quickly once you want to load them. I think I'm not sure if I shared the paper with you or not, but there is a wonderful publication that references does a compare time between scaling just WebAssembly processes versus optimized containers, and the optimized containers were 4 to 8 seconds to scale versus milliseconds for WebAssembly. So we really want to make sure that we have the right tooling and infrastructure to help. Our goal with wasmCloud is to give you a framework for building functional microservices quickly. What React does for HTML, we want to do for microservices and WebAssembly. So part of that means having not only the framework for building apps quickly, but structuring our logical components together into an idea of an application that has multiple different components here, and then to give you the facilities to commit to that, and then obviously then scale that or change that definition as you're moving through the life cycle of a microservice.
I mean, this is clearly a very important component, right? It's clearly needed. I was just trying to sort of figure out where this was.
Look, this is the fire hose for sure, and I appreciate you joined on Slack this week, and I appreciate taking the desire to come along and learn about what we're doing. I think it's really powerful, and I wouldn't be all in on this if I didn't genuinely believe that actors were the next epic of computing. you know, to me it's clear. You know, we're walking up that stair step of that infographic from we virtualize CPUs, we virtualize operating systems, we virtualize clouds, you know, VMs, containers, Kubernetes. Virtualizing each individual process feels like the next step with WebAssembly. So that way we have now CPU independence and a portable security model. And then the step after that is virtualize the libraries. So that's what we're trying to do, you know? Okay, awesome. Well, busy meeting today. We're almost at time. Just any last calls or other topics that people wanted to raise or just bring up? Okay, wonderful. Well, Ross, Nikki, thank you both so much for coming.
Liam, I have one thing.
Oh, sorry. Brooks, of course you do.
It's all good. I have one community call out for today. Oh, and I do need screen sharing, but I'll explain it while I wait for it. So for those of you who are new, we like to do a thing every week at the community meeting called a community call out. These are just issues across the wasmCloud organization that have good first issue on them, and they're a great place to jump in if you're looking to contribute for the first time. So today I have one. This is something more on the CI/CD side of things, but would really help improve our documentation. So when you go to start a capability provider with wasmCloud, the way that you can find the newest version of a certain capability provider is by coming here to the repository, finding the latest. So if we wanted to use, say, the NATS capability provider, and we take a look at the cargo.toml, we see that the latest version is 0.11.7. Or we can come to the releases page, and then we can try and search for NATS and find that should work, find the latest version 0.11.7. But we're kind of forced to do this because a lot of OCI registries don't support the content discovery part of the OCI spec. So it's a little bit hard to find like the latest version of a capability provider. So that's kind of the point of this issue. Would love a little bit of help making it so that the OCI reference that we published the capability provider to, if we can attach that specific OCI URL to something like a shields.io badge that's like right in line with the repository README. I don't know if that's, let me see if I can find one. I don't know if this is common knowledge or not, but a shields.io badge is something like this, where it's just like a little badge that's dynamically updated on the README. Would love to have something like that added to the capability providers repo, and all that information is available within our GitHub Actions. So just a matter of getting that out and putting it in the repository. That would be awesome, so that people are aware of like newer versions of capability providers, things like that. So if you're interested in taking on something like this, I'm going to post the issue link in the Slack, the community Slack as usual. Just drop a comment on that or drop a comment on the issue, and happy to help out.
Thank you so much, Brooks. Any last words before we end for the week? Busy meeting today. Thank you so much, everybody, for coming to wasmCloud Wednesday, as usual. I'll stop recording and we can hang out for a minute or two for our next meetings. Cheers.